Okay, let's take a look on answer 12 on page 28 from textbook. Okay, now one part of y is constant and the other part vary directly as x squared. Okay, so from this sentence, we know that this y is a variation subject. Is a variation subject. Okay, and this y is actually formed by two different parts. From the question, one part is a constant and the other part vary directly as x squared. Okay, so now then from the question we understood that the variation subject y is formed by two parts. The first part and then the second part. And we connect the partial variation terms with a positive sign, with addition or subtraction, okay? Well, and we will always assume addition first. Okay, and then let's go back to the question. The first part is a constant, okay? One part is a constant. Let's see it as the first part. Okay, if the first part is a constant, then what should we put inside the first box here? Okay, perhaps you may know that we should put a constant k here to indicate that this is a constant. Okay, and the other parts will vary directly as x squared. Okay, so if the second part vary directly as x squared, if we know that the second part vary directly as x squared, then we might put something like this in the second box here, which means the second part is actually something like kx squared. Okay, but please bear in mind that these 2k from the first and from the second part might not be the same. They may be different constants after all. So if we use the same symbol k to label them, it will be very inappropriate because the readers may think, the markers may think you are assuming the two constants to be the same value. Okay, so just like what I said today, we should add a lower script to indicate that these two k's are different k's actually. So we call the first one k1 and we call the second one k2. Okay, therefore actually we will say that y equals to k1 plus k2 x squared, where this k1, k2 cannot be 0. Okay, so that's how we solve problems involve partial variation. Okay, and then all we need to do is to substitute everything into the formula here. So because x equals to 2, y equals to 31, therefore we have 31 equals to k1 plus k2 and then 2 squared, which means 31 equals to k1 plus 4k2. So this is, and then the second part, because when x equals to 4, y equals to 19, then we have 19 equals to k1 plus k2 times 4 squared. So 19 equals to k1 plus 16 k2. Okay, so you might notice that actually we now have two variables, two unknown constants that we would like to find the value of them. Okay, they are k1 and k2, k1 and k2 respectively. Okay, so you might notice that actually this is in order to find the value of k1 and k2, we need to do simultaneous equations, solve equation 1 and equation 2 at the same time. Okay, so we label this one to be our equation 1, we'll label this one to be our equation 2, and then all we need to do is to do simultaneous equation. And by equation 2 minus equation 1, Now we have 19 minus 31. That will give us negative 12. Okay? And then K1 minus K1. We can see that the two K1s here will cancel each other out because K1 minus K1 equals 0. Okay? And then 16K2 minus 4K2, we have positive 12K2. So therefore, obviously, K2 equals to negative 1. And by K2 equals to negative 1, we have K1 equals to, from equation 1, we can see that 31 plus 31, yes, plus 4 equals to K1, so K1 equals to 35. Okay? And therefore, after all, we have Y equals to 35 minus x squared. Okay? The K1 become, the K2, the value of K2 become minus 1, so it gives us negative x squared. So that's all for A part. And in part B, we have to find the value of y when x equals 7. So simply because x equals to 7, therefore y equals to 35 minus 7 squared, so 49. 35 minus 49, that will give us negative 14. And that's all for part B. Okay, one thing that I didn't mention in the previous slide, on the previous instant drill, let's take a look together. Okay, from the last instant drill, we start from this thing, y equals to K1 plus K2 x squared. Okay, so some of you, I think you may wonder, in direct variation, in inverse variation, in joint variation, we always start from something like this. Y varies as K1 plus K2 x squared. Okay? But actually, we will not do the same thing in partial variation. Actually, I should warn you that in partial variation, we always start from this one. This one is correct. Okay? In partial variation, we never write something like this. We never write something like y varies directly as something. Okay? Why? Because if we try to elaborate, this thing, then we will have y varies directly as bracket K1 plus K2 x squared. And the next step will be y equals to the third K times this thing. Okay? Something that we have already finished in direct variation. Then this will turn the whole thing from partial variation to this one become direct variation. Okay? And if you write this, then it means that you mix up the two topics here. So bear in mind, in partial variation, we never write y proportional to ... Okay? We always directly start from y equals to some constant plus another constant times x plus another constant over z, okay, plus so on. Okay? And we will not write something like this anymore in partial variation. That's the one thing that you have, you really need to pay attention to, otherwise you will get it all wrong. Okay?